All right, here we go. This is for what, Wednesday, May 13th. We're making observations about two-dimensional motion. Now, I set a requirement that you had to watch the review video. It's only about 4.5 minutes, so hopefully that reminds you, and you can go back to it. The question is the motion constant velocity, right? Or is it constant acceleration? Or you could describe it, is it varying velocity, which is constant acceleration, or is it constant velocity? And you should see that in the position time graphs, because what I'm going to do is I'm going to go through a Logger Pro data analysis. I've already plotted the points, and I'm going to put up some graphs. I'll describe the graphs, but I'm not going to describe the motion. And what you're going to do in the description or this discussion board is describe the motion of the tennis ball as it moves horizontally. Describe the motion of the tennis ball as it moves vertically. So here we go. Let's see if I can play this again. I've got Hallie Stiff. She's one of our tennis players. We recorded it in the fall last year. And let's see, we'll play it again, right? You can hear her voices. We set it up, she hits, and all my data points plotting that motion, okay? Now what I'm going to do is I'm going to insert some graphs, okay? I'm going to insert a graph, and let's see what we can do here. I am going to graph X, and I'm going to graph time. Now the interesting part is I'm used to dots, but apparently they're going to give me a line. Now this is the x-axis, or x-axis. Let me move this over, okay, and kind of, maybe I can, move this over, not with my face, I'll put my face over here. And we'll look at it. These dots, this is my axis, my 0, 0. This dot says this is the positive x-axis. So what it's doing, it's observing the motion. It's just plotting. If I look at my data, each point has an x and a y set of data. Okay, each point. Let's see if I can get that to spread out. So let me go over here. Each point that I've plot has an x and y data. So this is really close to 0, 0. Okay, really close to 0, 0. And then the next one, all the x's are going to be negative. Why is that? Well, honestly, it's going to be negative because I've got the x, y, my x, positive x is to the right, so it's moving to the left. So I've got negative just means it's moving to the left. Now what I want you to do, right, it's basically separated this motion. It's looking at the motion in the x direction, horizontally, basically, what's its horizontal motion look like, and then we're going to look at the motion in the y direction, okay? So we're going to just look at the y values. So horizontally, what's this telling me? You've got a position versus time graph. What is this telling you? What kind of motion do you have, okay? If I go back to discussion board, ways to describe the motion, the position versus time graph for this would be horizontal motion is what? Therefore it has constant what, right? I want you to fill that in. So now let me go back to the data. So this is position versus time in the horizontal, right, motion. So let me insert another one, and I'm going to insert a graph, right? Now this is y velocity. That should give us a hint already, but I'm going to change that to the y position, okay? And that shows us this information. I'm going to scale that, right? And so if this is 0, 0 over on the video, right where she hits the ball, and it goes up, right? And it comes down. So it's just looking at the y data, okay? And it's plotting it. It goes up, and it goes down. What kind of motion is happening vertically? What I think is really cool is how different they are. Horizontally, there's a type of motion, right? Horizontally, there's a type of motion, and vertically, there's another distinct type of motion. Essentially, they can be isolated. As an object moves in 2 dimensions, meaning it has a vertical component and it has a horizontal component, they act independently. So let me insert another graph, right? And this is actually what I'd want to do. Let me see if I can shrink this up. So that's position versus time. Now this is velocity versus time. Now what I'm going to do also in this video, and I'll do this, and I hope I have the scale right, I'm going to do a linear fit, right? That looks pretty accurate. Okay, and I'm going to move this, and I'm going to, I know you can read that, but I'm going to, appearance, I'm going to make that a lot bigger. Okay. What does that mean, the slope? Okay, what's that telling us? All right, and then here, I can give you the slope. All right, and I'm going to enlarge that. What did I take it to 18? It's so big. Right, and you've got the slope for this. Now I'm going to, it's not the best, it usually doesn't give us great data, but I'll put out the position or velocity versus time, and let's see. It's usually not great data. X velocity. That's pretty good. Looks pretty what? What data can you get from that? Right? I look at that slope. So again, your job is to look at this data. I'm just putting the data out there, right? So you can kind of read this. I'm not sure if I'm going to be able to get another graph if I go one step further. It is not giving me anything else but velocity. What would I know about the acceleration versus time graph for horizontal motion and for vertical motion, right? So anyways, there you go. Use this data about the motion of a tennis ball moving, and I want you to draw some conclusions. It's about the motion horizontally and the motion vertically. Again, they looked so distinctly different, okay? So distinctly different. This is the coolest thing about projectile motion, okay? That you can isolate these and look at them separately. All right, that is all. Enjoy. I hope you take some time and look at those conclusions.